Good afternoon, and welcome to our lesson about probabilities involving the word or. For all intents and purposes, the word or means add. So, we have a list of students and their majors, and we already totaled it. It's 740. I want to know, what is the probability of a math or a science major? Well, let's see. First, there are 120 math majors plus 140 science majors. That adds up to 260. And now what we're going to do is, after we're done with that, we're going to divide that number by 740. And 260 divided 740 is 0.351. And that's all you do. Okay, the next question is, find the probability of math major or liberal arts major. Well, again, there's 120 for math, plus 110 for liberal arts. That adds up to 230. Once again, we're going to divide by the total, 740. And that is going to equal to 0.311. Like so. Now the next one's kind of big. Math major or business major or nursing major. Well, it doesn't matter how many there are. It works the same way. There's 120 for math, plus 180 for business, plus 190 for nursing. That is equal to 490. When you're done, divide by the total, which is 740. And 490 divided 740 is 0.662. That's all you do. Okay, so let's go back to our small town and answer some questions. So first it says, what is the probability that a person is 0 to 4 or 65 plus? Well, let's see. 0 to 4 is 2,500. 65 plus is 3,000. That equals to 5,500. When you're done, divide by the total, so divide by 30,000. And 5,500 divided 30,000 is 0.183. All right. All right, the next one says 19 to 34 or 46 to 64. Well, 19 to 34 is 8,700. 46 to 64 is 4,100. That adds up to 12,800. Next, divide by 30,000. And that is equal to 0.427. All right, the next one's a little bit tricky. 19 to 45. And I know what you're thinking. You're thinking, there's no 19 to 45 anywhere. You're right. No, there isn't. But 19 to 45 is the same as doing 19 to 34 plus 35 to 45. So, let's get some answers, shall we? 19 to 34 is 8,700. 35 to 45 is 5,300. That adds up to 14,000. Then divide 30,000. And we're going to get 0.467. Okay, the next one says 0 to 18. And again, there is no 0 to 18. But 0 to 18 is 0 to 4 plus 5 to 18. And we have numbers for those. So let's take a look. 0 to 4 is 2,500. 5 to 18 is 6,400. And that adds up to 8,900. Divide by 30,000, the total. And we're going to get 0.297. That takes care of that. Okay, so you're also going to encounter OR probabilities from a table. Now, in our first question, we have a table, and we'd like to find the probability of sophomore or junior. Well, no problem. We will first find the total sophomores, which is 127. Then find the total number of juniors, which is 86. OR means add, so we'll add them up and divide by 510. Well, sounds like a plan. Let's do that. 127 plus 86 is equal to 213. Divide that by 510. And we are going to get 0.418. All right, fair enough. Now let's look at the next question. It says find the probability of freshman or female. So the first step is to find all the freshmen, which is 237. Then find all the females, 304. Add it, so 541, and then divide by 510. But there's a problem. First of all, the probability is bigger than 1, which is never supposed to happen. And second, how can 540 people be something if there's only a total of 510 people in the room? We're missing something here. Let's take another look. Okay, so what I like to do is find the total number of freshmen. So what I'm going to do here is I'm going to circle the column with freshmen, and then I'm going to write the total next to, and I'm going to write down the total, which is 237. Okay. Next, what I like to do is circle the row with female. And the total for female is 304. Now here's why I did the circles. Do you see where the blue circle and the red circle cross each other? You may notice at 149. What happened here was 149 individuals got counted twice. Once for being a freshman and again for being a female. So in order to correct for this, we're actually going to have to subtract the cross. So what we'll do is we will add the females, add the freshmen, and then subtract the cross. Let's see what happens. So we'll do 237 plus 304 minus 149. That's equal to 392. Still divide by 510. And we're at 0.769. Much better, much better. All right, let's try this again for junior and male. So I'm going to circle the juniors. And I see that the total is 86. Okay. Now I'm going to circle all the males. And I see the total for males is 206. But do you see where juniors and males intersect? It intersects at 40. So that means 40 people got counted twice. Once for being a junior and again for being a male. So let's put this together. So junior is 86 plus male 206 minus 40, the cross. That's going to equal to 252. And then divide by 510, and we're left with 0.494. Okay, so we have a table like this. You want to find the probability that a voter is female or opposed to the tax increase. Well, the total number of females is 549. The total number of opposed is 671. And then notice that 383 intersects female and oppose. So, what we will do is we will do 549 for female plus 671 for oppose minus 383 for the intersection, the cross. That is equal to 837. Then divide by the total 1035, and we get 0.809. All right, so now what I'm going to do is I'm going to erase all this. Let's do another example. So here we're going to do male or support. So again, what I like to do is circle the male. So the total is 486. Circle the support, which is 301. And then find out where male and support intersect. Looks like at 171. So what we have is we have male as 486 plus support 301 minus the cross 171. That's going to equal to 616 divide 1035 or equal to 0.595. All right, excellent. Let me erase these lines. Okay. Next question is unsure or male. So first, let me circle unsure. Then let me circle male. And I see they intersect at 27. So we're ready to put this together. The total for unsure was 63, plus the total for male is 486, but then minus the cross, 27. That's all equal to 522. And then divide by 1035, and we're left with 0.504. All right, now this next one's tricky. What is the probability that a voter is not unsure or female? Well, first of all, before we can do that, I have to explain what not unsure even means. All right, well, if someone is not unsure, then that means they either support or oppose. So the question is really support or oppose or female. All right, let's answer those. So first, I'm going to circle for support, which I did. Then I'm going to circle for oppose, which I did. Then I'm going to circle for female, which I did. And now I'm going to identify the cross, or should I say crosses. In this example, there's two crosses, one at 130 and one at 383. So this is going to be a big one. All right, so first we'll start with support, which is 301, plus oppose, 671, plus female, 549, minus the first cross, 130, minus the second cross, 383. So a lot of numbers here. That adds up to 1,008. Then finally divide by 1035, and we get 0.974. So watch out there. That's a tough one. Not going to lie to you there. Let's do another one. All right, so how often they exercise, and the question is frequently or occasionally. Well, I circled the frequently, and I circled the occasionally. So notice in this example, normally I have to do minus a cross, but do you see a cross? You do not. So in this case, we're going to subtract 0 because there is no cross. What we'll end up doing is we'll do the total of frequency, 422, plus occasionally, 832, minus 0 because there's no cross. That is going to add up to 1254. Then we'll divide by 1894, the total. So 0.662. All right, next question. Well, before doing that, I'm going to erase these lines so I can use it again. All right, female or never. So first I will circle the females. Then I'll circle the nevers. And I see that it intersects at 338. So we're going to subtract that a little later. Let's see what we get. So total females is 971. Plus total never, 640. Minus the cross, 338. That's equal to 1273. Divide 1894. And that's going to equal to 0.672. All right, next. What is the probability of male or frequently? Well, let me get rid of this junk. So first, let me circle the males. Then I will circle frequently. And then I see it crosses at 209. So we will first do males, which is total 923. Then frequently, which is total 422, minus the cross, 209. That's equal to 1136, divide 1894, and that rounds up to 0.600. All right, the next one, it's another trick question. Female or not frequently? Not frequently means it's either going to be occasionally or never. So the real question here is female or occasionally or never. All right, let's answer that. So first I will circle the females. Then I will circle occasionally. Then I will circle never. Notice this time I see two crosses, one at 420 and one at 338. So we will be subtracting two numbers. So let's put it together. So first the total number of females, 971, plus the total for occasionally, 832, plus the total for never, 640, minus the first cross, 420, minus the second cross, 338. If we throw that in, we're going to get 1685, divide 1894, and that's equal to 0.890. And that takes care of that. Okay, so now you may have or probability with words. It's pretty easy. All we're going to do is add and then subtract the both. So when we do the probability of selecting a student that's a female or physics major, what we're going to do is do all the females plus the physics majors and then minus the ones that are counted twice, which I call both. All right, so let's take a look. So first there are 13 females plus 12 physics majors, but there are 4 students that are both female and physics majors, so subtract 4. That equals to 21, divided by the total of 40, and we're left with 0.525. All right, next is male or math major. Okay, well, I can handle that. First, let's get all the men, the males, so 18, plus all the math majors, 20. But then we have to subtract the male math majors, which is 6. That's equal to 32. We're going to divide by 36, so we get 0.889. Okay, so the next question, example 9. First, we need all the marbles that are red, which is 19, plus all marbles that are striped, 12, minus 7 because there are 7 marbles that are both red and striped. That's going to equal to 24 divided by 30. It's equal to 0.8. So actually, that concludes everything we learned about probability and OR. In fact, it concludes everything that's about Chapter 3. Test 2 will cover both Chapter 3 and Chapter 5. So as of right now, you've learned half of Test 2. Later on this week, I will post notes for Chapter 5, and I'll also post notes for Chapter 4 because there's a quiz on Chapter 4. Just stay tuned, keep looking at the announcements. Let me know if you have any questions. Otherwise, have a great afternoon.